Our next problem features a ball of moist clay that falls some distance to the ground, and then it travels, once it hits the ground, it travels some extra distance before stopping, or it travels some extra distance over some time before stopping. So first it's going to fall a height h, I'm going to call it, and then it's going to travel some other distance, I'll call it d, before it stops, over a time delta t. We're given delta t and given the height, and so we want to find the average acceleration of the clay, or fing rate. Find a average while it's in contact with the ground and treat the ball as a particle. Okay, so first we want to find out how fast it's going when it hits the ground. I'm going to call that v. I don't know, I'll call it v. I'll just call it v. Okay, how fast it's going when it hits the ground. So v, we know how far it fell, right? This height h, so let's say v squared equals its initial velocity squared plus, so let's see, this is going to be, so actually let's do minus 2g delta y. Well, delta y was negative h, right? It started, if we use our convention that positive y is upwards, then it starts at a height h and ends at 0. So actually delta y is negative h, which means, which means this term is going to become positive 2gh here. And then its initial velocity was 0. We're sort of assuming it was dropped. It says a ball of moist clay falls 10.6 meters to the ground. So I think that's, or some distance to the ground. So I'm gonna use, say this was 0. It just started at rest and fell. So it just started at rest and fell. And so v squared is 2gh. Okay, so that's pretty easy. And then when it gets here, it goes some distance d, and then it stops over a time t. So really all we have to do is figure out how long it takes, or how much acceleration it needs to do this. So v squared is 2gh means v equals square root of 2 times g times h. That's pretty easy. Now, so we're going to call that, I'm going to sort of do it as though we're starting a new problem here, and I'm going to say we're starting from here where v naught equals negative square root of 2gh, and then ending here where v equals 0. And so we want to find out what its average acceleration was. Well, v equals v naught plus a times t, right? Well, v, so this final v is 0. 0 equals, this v naught was negative 2gh. And so we can say, again, this is our positive y direction. And acceleration then was something. And then we were given, actually, the time it takes, which I'm going to call delta t here. So then you just find, basically, should be pretty easy to show then. You just pull this over to this side and divide through, and you can show that a equals 2gh over delta t is its acceleration. The question then, of course, is, because this is, again, silly little WebAssign thing. So I'll tell you what, let me plug my numbers in. So for my numbers, of course I have g equals 9.8, we all know that. I have h equals 10.6 meters. I have delta t equals 19.5 milliseconds. So I'm going to say 19.5 times 10 to the minus 3 seconds. And if I plug all these in, then I should get, let's see, so 2, whoops, okay, hold on, back over here, remember I plugged in v naught, that should be negative square root, that should be square root there too, because velocity is the square root of that, is the square root of 2gh, right? Here's where we found it. So almost screwed the pooch on that one. So let's try, let's see, square root of 2 times 9.8 times 10.6, close parentheses, and then divide that by 0.0195 and see what I get. So I get, where's my little thingy? I get, hope I'm still recording. Oh yeah, there it is. All right. Average acceleration for me equals 739 meters per second squared. What direction is that? Well, at least that's what WebAssign wants us to tell them. So over here, here's our silly little WebAssign thing. A ball of moist clay falls this part of the ground. What's the average acceleration during the time of contact with the ground? So let me try that first. And I'll put in 739 and see what WebAssign says. And, whoo, yeah. And then which direction is it? Well, it was going down to begin with. So if it was going down at the beginning and it ends up with 0 velocity, not going up or down, it must have had some up acceleration. So that's what I'm going to do. And boom, and of course I'm sure that is right. So okay, so fantastic, there we go.